Welcome to the Wellbore Genie Tips and Tricks Tutorials. In this video, we're going to cover how to build a sidetrack. For this example, we'll open up the builder and load and draw a pre-saved vertical well of which we'll build a sidetrack from. As you can see, there is already a cement plug in place to plug off the original production. The method for drawing a sidetrack is first to draw the original wellbore and then draw a sidetracked wellbore on top of the original wellbore. There are a few parameters that must match the original wellbore and the sidetracked wellbore. These are important. Number 1. On the Page and Well tab, the page grid and drawing range values must be exactly the same, else the wellbores will not draw perfectly on top of each other. Number 2. On the Page and Well tab, you should always have the locked TVD scaling box checked, and the value in the box needs to be the same for both wellbores, else they will not be scaled correctly to each other. Number 3. On the Casing tab, both wellbores must have the same exact scale factor, else the casing scales for the wellbores will not be proportional to each other. Number 4. The bore factor must be set to 1. The bore factor increases or reduces the bore diameter as a factor of the smallest casing or tubing. If the wellbores have different size smallest tubulars, they will not be proportional to each other even if the bore factor is set to the same value in both wellbores. It must be set to 1 and 1 only. To avoid errors, many times it's safest and easiest to start the sidetrack wellbore with the data already in the original wellbore. So the first thing we'll do to start this sidetrack is to change the name on top to Sidetrack 1 and save it in slot number 2, right below the original hole. Before we start the sidetrack, we'll go ahead and add the vertical scale to the page. Now let's go to the Page and Well Path tab. You can either import a survey path for the sidetrack or design from the built-in well profiles. Remember that if you're using imported surveys, the survey for the original hole and the sidetrack hole must be identical from the surface to the sidetrack depth. If not, your wellbores will not line up properly. For this example, since our original hole was drawn from a vertical built-in profile, we'll use the S-curve profile for the sidetrack. So we'll go ahead and check the box for S-curve. Now we need to enter the well path parameters. Our kickoff point will be the sidetrack depth. We'll set that at 3,000 feet. Before moving on, it's important to understand how scaling affects the visuals with sidetrack wells. We'll use Excel shape tools underneath the Insert tab to draw a simple double arrow line across the center of the wellbore. We'll set the width of the line to 0.6 inches in the Format window, which makes it pretty close to matching the width of the bore. Now we'll take this line and rotate it 90 degrees and move it over to the vertical scale for perspective. As you can see, the bore of this well is a little more than 400 feet wide when compared to the vertical scale. When drawing a sidetrack, we have to keep this in mind. If our sidetrack is only 50 feet or so away from the original wellbore, then the sidetrack portion will be overlapping the original hole. So when drawing a sidetracked well, we have to exaggerate the separation distance to get the appropriate visual. Going back to our S-curve well, we need to put a large kink in the well to get it away from the original wellbore. We'll make the build rate 15 degrees, the tangent inclination 60 degrees, the slant length 1,000 feet, the drop rate 15 degrees, and the final inclination back to 0 degrees. If we want this sidetracked well to go down to the same 6,000 foot TVD as the original hole, we'll need to adjust the measured depth. Using the Calc Max TVD tool, we can see that we're only at about 5,357 feet TVD, which puts us 643 feet short of the original hole. We can change the measured depth at TD to 6,643 feet, click the Calc Max TVD button again, and that will get us down to our 6,000 foot TVD where we need to be. Now let's move over to the casing section. We'll assume that we plan this sidetrack well to be completed with 4.5-inch casing. We can leave the surface casing as it is because it doesn't change for the sidetrack well. However, casing string 2 will need to be modified. Because we're kicking off at 3,000 feet, we'll set the bottom of the 7-inch casing to 3,000 feet and we'll change the cement to none. We also want to uncheck the shoe box because we don't want a 7-inch casing shoe appearing at 3,000 feet. Now we'll enter our 4.5-inch information with a 6 1/8-inch hole and the top depth at surface and the bottom depth at 66.43 feet. Let's give it lead and tail cement to surface with the top of tail at 4,000 feet. And that will complete the casing section. Since the original hole has lead cement above 3,000 feet, we need to go to the annular fill tab and check fill 1 and fill the 7-inch annulus, which is casing number 2, from 0 to 3,000 feet with light cement. Lastly, we need to go to the perforations tab and uncheck the perforations, and go to the plugs and bore fill tab and uncheck the plug back cement fill from the original hole. Now we'll click draw, and there's our nice, clean, sidetracked well. Notice that when I click and move the sidetrack well, that it is a replica of the original hole from the sidetrack depth of 3,000 feet to surface. We can also draw this sidetrack to the left of the original hole by going to the Page and Well Path tab, and down in the Scaling Controls section, change the casting to left. We'll click refresh, and now it appears on the left of the original hole. For the last step, we'll add a whipstock to the sidetrack from the Elements menu. Using the Rotate Excel tool, we'll flip it horizontally and then drag it into place. Finally, if we want the whipstock to appear behind the sidetrack, we can just click the Send Backward button in the ribbon. And we'll call this a completed sidetracked well. This concludes this tips and tricks tutorial. Be sure to check out more videos to learn about all the features of Whalebore Genie.